Hello, in this video I will explain how to work with G-Power. G-Power is an app that you can download from the internet safely just by typing in G-Power download, and it will be usually the second hit. So please download from the official university website of the German university. There you can download G-Power, and when you open it, it opens this window, and I'm going to explain to you how to calculate two types of power analysis. The first one is a priori, which means that you're going to compute the required sample size. So this is when you did not complete a study yet, and when you are setting up your own study and collecting your own data. Because a priori means beforehand, and what you're going to do is calculate how many participants you need to have enough power to find a certain effect. Then the other way is the post hoc, and a post hoc power analysis is to compute achieved power. So this is when you're using data from a study that's already been completed. So what you're going to do post hoc, afterwards you're going to calculate how much power there was achieved given the number of participants that were collected. So for both you can select several tests, and this can be difficult because there are so many options, but for now we're going to just look at the default, which is t-test and correlation. If you already know that you're going to perform different type of analysis, for instance, if you know that you're going to look at different groups, then you have to click on different groups. This is for when you're going to look at one group of participants. So we only have also only one number of participants. Quickly going to show you, if you do this, if you click means difference between two groups, for instance, you will see that you have options to filling out the number of participants that you have per group. So for now we're just going to do correlations, and we're going to do a priori, like I said. So beforehand you're going to calculate how many participants you need. So I usually do two-tilt testing because you usually don't really know what the effect will be. So select two sample t-tests. The effect size, when you hover over this, you can see the rules of thumb. So it is on default on a medium effect size of 0.3, a small is 0.1, and a large is 0.5. When you're setting up your experiment, you can think about what type of effect you think you will find. Is it a large effect, a medium effect, or a small effect? If you have all the time in the world, all the money in the world, I would go for a small effect, but you can already guess that when you want to detect a small effect, you need more participants than when you want to detect a large effect. So let's keep it on default in the middle at 0.3. Then this is your p-value that you set for when you think something is significant or not. So usually, also rule of thumb, we're going to use 0.05. So a p smaller than 0.05. So this we leave like this. And then the power, sometimes you want a really high power, but the rule of thumb is that you need a power of at least 80. So let's see what happens if we how many participants we would need for detecting a medium effect size with a power of 0.8. Then you hit calculate, and here you can see that we needed a sample size of at least 82 participants. Then we can play around a little bit. Maybe you want actually a power of 0.5 or 8.5. Then you already need a little bit more participants. Also always think about attrition. Sometimes maybe you have exactly 82 participants. Don't go for that because there's always participants that don't come, or maybe the data doesn't look good. So I would always go a little higher for this when you do a priori. So this is a priori. What you report is that you need 82 participants to achieve a power of 0.80 or higher if you want to be able to detect an effect size of 0.3. So let's do point A1 for the just for the fun, and then you see you need lots of participants. So for detecting small effects, you need very large groups of participants. Okay, now let's go post hoc. So computing the achieved power. So let's say you received data. You received data of 150 participants, for instance. That's a pretty good group. And you're going to report in your research proposal, for instance, or in your final thesis, what the power was, what the achieved power was to detect certain effects. So you're wondering maybe whether you are able to detect an effect size of 0.1. Probably not, because we already saw that we need a lot. And indeed, the power, if we have 150 participants, the power to detect an effect that is small is very low. So the very low as in only 0.2. So the question here is, are we able to detect effects that are medium? Yes, we are. So with a sample size of 150, we are able to detect a medium effect size in our study with a pretty large power of 0.97. So a lot of people working with EEG data, they might have smaller groups, so maybe only 50 participants, and then we see that even a medium effect is very hard to detect. So here we look at large effect, and we are still able to detect effects of 0.5, so a large effect. So depending on the size of the data set that you received, so the size of the sample, this is what you're going to report. You could, for instance, say that you were able, or that you will be able to detect only large effects, but not medium effects, for instance, given the sample size. Or when you have a really large data set, you can say that you are even able to detect small effects. Okay, this was the video. I hope it was useful for you, and if there are any questions, please email me.